Hey everybody, welcome back. Today I'm going to get into the activity coefficient. So my objectives for today are going to be ways to model the activity coefficient, or I'll refer to it as gamma as well in my video. So ways to model it from experimental data. So the three different fit functions I'm going to show you are the Redlich Kister, Margules, and Van Laar. So just a little intro. We know that the mole fraction in the vapor, the mole fraction in the liquid, pressure and temperature, these are all easy things for us to measure in a lab. So we're going to use these as a way to model our gamma. So if we go in the lab and we get some experimental data on, let's say, methanol, and then we're like, okay, we want to write some model for gamma. Well, the ways I'm going to show you today, those are going to be used, these fit functions are going to be used using these four properties here. So maybe I'll write like measured to get a correlation for gamma, or the activity coefficient. So again, why this is useful is in my last video, I spoke about fugacity and the importance of fugacity. And you can see that in this equation, which is the equation that you guys are always going to start with when you're dealing with fugacity problems, is that we have the activity coefficient here. So in real life, if you're working in a lab or something and you're studying some species and you've got to calculate the fugacity, well, finding this gamma isn't going to be that easy. You're probably going to have to go look for a model of it somewhere. Or you're going to have to do some experimentation and find that gamma. All right, so here we go. So basically what we're going to be doing is we're going to be using excess Gibbs to model gamma. So like I said, the three fit functions that we're going to use are going to be the Redlich Kister, the Margules, and the Van Laar. So here under number 1, I've written Redlich Kister, which is referred to as a single term. So you can see here that on the left-hand side of my equation, I have the excess Gibbs over RT, which is the universal gas constant, times temperature, is equal to A, which is a constant, times your x1, x2. So the mole fraction of species 1 and species 2 in the liquid phase. And then underneath that, I've actually shown you that the ln of gamma 1 for species 1 is equal to AX2, and these A's are the same A. So the A you get for the top is going to be the same A you get for the bottom. This is going to make more sense when I really explain thoroughly in the next few slides how I'm going from excess Gibbs to the ln gamma. And then the next fit function I'm going to show you guys is the Margules. So here I've written the first thing you're going to find is the excess Gibbs over x1, x2 RT is equal to A12 plus A21 minus A12 x1. So again, these A's here are all constants. These are constants. And then these are going to be used for equation number 2 below to fill in here. So for both of these, the Redlich and the Margules, what I've written for number 1 is the first thing we're going to find. And then we're going to use those constants for equations number 2. So this equation 2 and this equation 2 to write our correlation for our gamma. So some useful equations we are going to need, which we're going to keep in mind throughout as I'm explaining the different correlations, is that ln gamma of species I, so here I don't have to write 1, I can just write species I, sorry, sometimes I forget to dot my I's, is equal to ln of P mole fraction in the vapor over mole fraction in the liquid, P sat. And then the partial molar Gibbs excess over RT is equal to ln gamma I. And then number 3 is also an important one. So just kind of keep these in the back of your mind for now. And these 3 equations are going to be used for all of the fit functions. So we're going to use them for Redlich Kister, we're going to use them for Margules, and we're going to use them for Van Laar. So this is for, I'll write that here. Oops. For all of the fit functions I'm going to show you today. All right, so to start, like I said before, the whole point of this video is to find a way to model our activity coefficient. So in this course, you are going to see 3 different ways to model gamma, or in other words, the activity coefficient. So the first way is Margules, second Van Laar, third Redlich Kister. And now I'm going to explain to you guys Margules, then Van Laar, and then Redlich. So I'm going to go through each one. So under this, I've written the steps that apply to no matter what model you are using. So whether you're asked on a test or on a final exam to find a model using Margules, Van Laar, or Redlich. These steps apply to all 3 of the fit functions. So the first step you're always going to do is you're going to have data. A data will be given to you, and you're going to be given your xi, yi, pt, let's say. So you're going to be given this data in a table probably because it'll be experimental data. And the first thing you're going to have to do is you're going to have to find your p sat. So I've already explained Antoine equation in my past videos, but you're going to have to use your Antoine equation. So you know the Antoine equation is ln p sat is equal to a minus b over t plus c. So from the table you're provided in your equation sheet, this is the equation. And this temperature is going to be in degrees Celsius. And then this A, B, and C are constants that you just get from your table. So constants. The second thing you're going to do is what I showed you before on my last slide. So I said keep these equations in mind because they're going to be useful. And now we're going to start applying them. So first of all, you're finding your ln p sat. Number 2, you're using modified Raoult's law, and you're going to have to assume this. You're going to have to say, yeah, modified Raoult's law can be used, okay? So that's going to be your assumption that you're going to have to make, and then you're going to use it. So you're going to calculate your ln gamma I, okay? So you're going to have your P, your pressure, your Yi, the mole fraction in the vapor, and your P sat, well, that's just what you calculated in step 1, okay, from step 1. And the Xi, that's going to be also something you're going to find in your table. And then step number 3 is after you've found, so usually you're going to be dealing with 2 species typically, and these equations they're used for 2 species. So for step number 3, you're gonna do ln gamma I. You're gonna do it for species 1 and species 2, and then you're gonna have these here. You're gonna be able to plug them in. You're gonna have your x1. You're gonna have your x2. Those will be in the table you're given, and then you're gonna use those to find this. You're not isolating for excess Gibbs. You're just finding, for example, like it's like this: GE over RT is equal to 5. You're not plugging in the universal gas constant and the T. You're just going to say GE over RT is equal to 5. Okay? So yeah, then number 4, this probably should have been one of the first steps that you're doing, but it's to set up a table. So typically what it's going to look like is that you are going to have this information. So you're going to have your X2. You're going to have your Y2. Maybe you won't have X1, Y1. So you're going to start filling these in, okay? So this is easy. You just do 1 minus your X2, and then for your Y, 1 minus Y2. Okay, really, really straightforward. Then, like I said, you're going to find your ln gamma 1 and your ln gamma 2, which was step number 2 right here, modified Margules' law. So you're going to do this equation. So these here are going to be modified Margules' law. I think that was my step number 2, if I'm correct. Step 2, let me just make sure. Yes, and then step number 3 is you're going to find GE over RT. So again, like I'm saying, you're not going to multiply your right-hand side by RT. You're just finding GE over RT. And the way we're going to find that is what I showed you on the last slide. So this is going to be step 3 that I showed you. And it's going to be your x1 ln gamma 1 plus x2 ln gamma 2. Okay, so these 4 steps that I've showed you are going to apply again. I'm just going to repeat it for all of the fit functions. You're going to need to do this, okay? So no matter which one you're asked to find, you're doing this. Now I'm going to go through the steps for each specific fit function that you're going to see. So the first one is, let's say, Margules. So after you've done those 4 steps, you're going to be like, okay, now I've got to do something specific because I'm dealing with Margules. So the first step you're going to do is you're going to add to your table. So we filled up this table. Let's pretend this is all filled. Here we go. It's all filled, okay? We've already gotten all this information. The next thing you're going to add, so you're going to have, let's say it's like a few lines. Like this is line 1. Like it's all experimental data. That's line 2. You're going to add this to your table. You are going to add the following. Maybe I'll do this in orange here. You're going to add this column. And I mean, this is just because it is pretty tedious. It's good to honestly write it because if you're on an exam or something and you do mess up, if you don't have all this saved on your calculator, which usually if you're doing some linear regression or something, it will. But I mean, if it's not, it's something that you can just write down. It takes a millisecond to write this, and it's good to keep track of to make sure your numbers that you're plugging in on your calculator are making sense. Okay, so again, just to repeat, this GE over RT is what I just showed you. So same way to find it for all of them. All right. All right, so the next step is to do your linear regression. So this is something you probably learned in stats, how to do it on your calculator. And if you don't know how to do a linear regression on your calculator, honestly, just Google it. It's super, super simple, and you're just plugging in x and y values, and it's going to give you an equation of a line. That's what you're doing. So when you're doing your linear regression on your calculator, for your y values, you're plugging in this column we just added. So your y values are going to be x is Gibbs over RT, x1, x2. This is what you're plugging in for your y. For your x values, you're plugging in your x1. Okay? Pretty straightforward, not too complicated. So what you see is you'll get an equation of a line. Your calculator is going to give you something that looks like this. Y is equal to ax plus b. Okay? But for Margules, the fit function is the following. So it's what we have here. You're going to have this y GE over x1, x2, RT is equal to a21 minus a12 x1 plus a12. So you can think of this as your a, and you can think of this as your b. Okay, so you're going to have your b. So you're going to have, like, it's 5, let's say. And then you can easily just solve for your a21 here, because you're going to have some a here, and you're just going to subtract it. Okay, so you're just simple. Yeah, so basically this whole step number 2 is to find, the whole goal of it is to find a21 and a12. That is what you're finding. That is your goal. So I'll write that here. Goal, find these constants. Find a21 and a12. That's the goal. So that's what I just said. So step number 3 is now we have some equation of a line. So you found your A. Here's your A. And you found your B. Here we go. And we've solved for our A21 and our A12. We've gotten that. So now, since we're doing Margules, we're going to look at the fit function for it. So our function for gamma. This is the whole goal of this. So this is number 2 under Margules. So now all we have to do is we have to write this equation. So whether you're writing in terms of gamma 1 or gamma 2 doesn't matter. So let's say we're doing gamma 1. Now you're plugging in your A12 here, A21 here, and A12 here, 21 and A12 there. Okay? So your final Margules equation should look something like ln gamma 1 is equal to x2 squared. And green here, I mean constants, okay? So this is going to be some constant, A12, plus 2, A21, minus A12, and then times x1. Sorry, I ran out of room there. Okay, so pretty straightforward. And you're going to see when I do the next one for Van Laar and for Redlich, it's going to be the same procedure, almost the same procedure. All right, so for Van Laar, you're going to ask yourself, okay, so same thing. You're going to add to your table. Same thing as we did for Margules. So what we're going to be adding to our table is the following. Maybe I'll put this in this color. We're going to be adding 1 over GE divided by RT times x1, x2. That is the new column we are adding, okay? So the new column we're adding is going to turn out to be our y in our linear regression. So you're going to have x1, x2, RT over Gibbs XS. And again, another reminder is this here is one number, okay? This is one number. So this is a number, okay? And then the x that we're going to be doing, that we're going to be plugging in on our calculator, the x values you're going to be plugging in are going to be your x1s, okay? So pretty straightforward. So again, the same thing's going to happen. You're going to get, your calculator is going to give you y is equal to ax plus b. It's going to give you an equation of a line. That's what's going to happen. And you know that the fit function for Van Laar is the following, what I've written in blue here. So that means that this here is our b, and this here is our a. So we can solve for our c prime really easily. And then depending on what b is, we'll just do b prime minus c prime is equal to b. And since we have c prime from the a we've gotten, we've just divided it by 2. We can solve for our b prime, okay? So again, our goal from this linear regression, goal to find the constants, to find b prime and c prime. That is the goal, okay? So step 3 is now we've gotten these constants. So we've gotten b prime, we've gotten c prime. Okay, here's c prime. We've gotten them. We've gotten these constants. Now we have, I'll add that here. Now we have constants from our linear regression. So now we've got to calculate our a12 prime and our a21 prime, which is from these equations down here. So really easy, really not hard to calculate. Literally just doing 1 over b prime and c prime. And then our step number 4 is writing out the function for our activity coefficient. So here, the only time you're going to have constants, I'll mark it in red, you're only plugging in these numbers, the ones you've solved here, okay? The rest of it you're not plugging in x2 or x1. We're just writing the the fit function, okay? So x2, x1, x1, x2, they're going to stay there, okay? We're just plugging in the constants we just found for a2, 1 prime and a1, 2 prime. All right, last one is the Redlich Kister. Sorry, I started you guys off with the hard ones, so now this should be really, really easy for you. So for the Redlich Kister, yeah, the only thing you've really got to add to your table is x1, x2. So maybe I'll just remind here. Add x1, oops, times x2 to table. And really, I like writing this down. You might think it's a waste of time, but honestly, when you're in an exam or something and you've got to recheck your values, it's better to have it written down than lose it on your calculator during exam and start freaking out. If you just write all your work, then it shows that, you know, you really did do the work and you might get points, okay? So always write this down, guys. It's like the best advice I can give you. So for Redlich, when you're doing your linear regression, the y values are going to be plugging in is the GE over RT, which again, I said before I started getting into these fit functions, the steps that apply to all of them, GE over RT will be in your table that you've made. And the x is going to be your x1 times x2. Okay, so again, you're going to find your equation of the line, which is going to be y is equal to ax plus b, and you're going to use the following fit. So you're going to use excess Gibbs over RT,